Hello students, let us continue the session on areas related to circles. In this session, we shall continue solving the exercise 12.1. There is a general instruction that unless stated otherwise, use pi is equal to 22 by 7. First question is, the radii of two circles are 19 centimeter and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumferences of two circles. As per the question, the radii of two circles are given. These are R1 I'll consider as radius of the first circle, which is 19 centimeter, and R2 I'll take as the radius of the second circle, which is 9 centimeter. And the radius of the circle which has the circumference equal to the sum of the circumferences of the two circles, I'll consider R as the radius of the third circle. So let me mention that let the radius of third circle be R. So as per the radii R1 and R2, we shall find out the circumferences of the two circles. So the circumference of first circle is 2 pi R1, which is 2 pi times 19, which is 38 pi. And the circumference of second circle is 2 pi R2, which is 2 pi times 9, 18 pi. And the circumference of third circle is 2 pi R. According to the question, circumference of third circle is equal to the circumference of first circle plus the circumference of the second circle. We shall make use of this relation. So circumference of first circle is 38 pi, circumference of second circle is 18 pi, and the circumference of the third circle is 2 pi R. So we shall equate it. Here I'll write 2 pi R equal to, I'll take 2 pi common, I'll be getting 19 plus 9. So 2 pi, they get cancelled. R will be equal to 28. So the radius of the third circle is 28 centimeter. Question number 2. The radii of two circles are 8 centimeter and 6 centimeter respectively. Find the radius of circle having area equal to sum of the areas of two circles. In the earlier question it was circumference. Now in this question we have to consider the areas. Let me write radius of the first circle to be R1, which is 8 centimeter, and the radius of second circle is R2, 6 centimeter. Let me consider, let the radius of third circle be R centimeter. So according to question, area of the third circle is equal to area of first circle plus the area of second circle. Area of the third circle is pi r square, which is equal to radius of first circle is pi r1 square plus pi r2 square. So I get the relation r square is equal to r1 square plus r2 square, because the pi values, they get cancelled. So r square will be equal to 8 square plus 6 square. We get it as 100. So the value of r will be root 100, which is 10 centimeter. So the radius of the circle is 10 centimeter, where area of the circle obtained is sum of the areas of the other two circles. Question number 3. Figure 12.3 depicts an archery target marked with its 5 scoring regions from the center outwards as gold, red, blue, black, and white. The diameter of the region representing the gold score is 21 centimeter. It's a diameter. Each of the other bands is 10.5 centimeter wide. The width of each of the band is 10.5 centimeter. Find the area of each of the scoring regions. There are 5 scoring regions. We need to find areas of those 5 scoring regions. For the convenience, I have taken the same figure with the measurements. The 21 centimeter is the radius of the gold score, and then followed by 10.5 centimeter width. So gold region is 21 centimeter. Next region, red region, the radius is 31.5. Sorry, the diameter is given, right? Diameter is 21, so the radius will be 10.5. Now let me mention the radius of the gold region, which is first circle. So radius of first circle is 10.5. It's not 21, because 21 is the diameter. Radius of first circle, which is gold region, which is 21 upon 2, it is 10.5 centimeter. Radius of second circle, we need to add 10.5 along with 10.5, because the width of this region is 10.5 centimeter, so the radius becomes 21, and the radius of the third region, third circle, which is blue, is 21 plus 10.5 is 31.5, and the radius of fourth circle, which is black, is 31.5 plus 10.5, we get 42. It's in centimeter. The radius of fifth circle, which is white in color, is 42 to be added to 10.5. We get 52.5 centimeter. They have asked to find the region of each color, each scoring. So area of The first circle will be pi r1 square. If I call this radius as r1, this as r2, this is r3, this is r4 and r5. The radius of the first region, area of gold region, is pi r1 square, which will be equal to pi times 10.5 whole square. We need to simplify this further. 10.5 into 10.5 we need to do with the value of pi. The value of pi, they have not mentioned that use 22/7, so let me consider 3.14 multiplied to 10.5 into 10.5. Simplify that. Approximately we get 346.50 centimeter square. This is for the gold region. So area of red region will be area of the second circle minus area of first circle. What is area of the second circle? We need to consider the radius to be 21 and we need to find the area, minus we have to consider the radius as 10.5 and then find area. The results are to be subtracted, then we get area of the red region. Therefore, the area of red region will be pi times 21 whole square minus pi times 10.5 whole square. Further, when we simplify, we get 441 pi, this is 21 square is 441, minus 110.25 pi. Subtract it, we'll be getting 330.75 pi. Pi value, if you take it as 3.14, approximate value we get it as 1039.5 centimeter square. This is the area of red region. Now I'll find out the area of blue region. So the area of blue region will be equal to area of the third circle minus the area of second circle. Area of third circle minus area of second circle. Area of the third circle, we have to consider r3 cube square plus pi times r2 square. So let's substitute. So pi times 31.5 whole square plus pi times 21 whole square. So when we find 31 square, it is 992.25 pi minus 441 pi. Upon subtracting, we get 551.25 pi. Pi value taking 3.14 and then multiplying, we'll be getting 1732.5 centimeter square. Similar way, we'll find area of black region. So area of the black region is area of the fourth circle, which is pi r4 square minus area of the third circle, which is pi r3 square. On substituting, we get pi times 42 square minus pi times 31.5 square. We get on simplification 2425.5 centimeter square. You can very well cross check the answer, and the area of white region will be equal to area of the fifth circle, which is pi times r5 square, minus area of the fourth circle, pi r4 square. R5 will substitute r5 and r4, so pi I'll take as common, 52.5 whole square minus 42 whole square. Either you can simplify and then subtract, or else use a plus b into a minus b identity. You will be getting the answer as 3118.5 centimeter square. This is how we will make use of area of ring formula to find area of those regions. Question number 4. The wheels of a car are of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at speed of 66 km per hour? They have given the diameter of wheel. Once the diameter is given, we can find the radius. They have given diameter of wheel as 80 centimeter. So the radius of wheel will be equal to half of that, so 40 centimeter. We can find out the circumference of the wheel. So circumference of wheel will be equal to 2 pi r. We'll substitute r value as 40. We get 80 times pi. It's in centimeter. They have mentioned the speed of car, which is 66 km per hour. Since it is there in centimeter, we need to express in terms of centimeter. So I will convert this kilometer in terms of centimeter. If I consider 1000, it becomes in terms of meter. That meter we need to convert into centimeter. So I'll multiply one more 100. Now it has become in terms of centimeter. Since they have mentioned 10 minutes, this hour I'll convert into minutes. So instead of 1 hour, I'll consider 60 minutes. So I'll get in terms of centimeter per minute. We can simplify, one of the 0 get cancels here. 11 times is 66. So 11 multiplied to 1 will be 11, followed by the same number of zeros. So we get 1,10,000 centimeter per minute. What does it mean? It means that in a minute, the car can travel 1,10,000 centimeters. They have asked the distance covered in 10 minutes. So I need to multiply 10 to this number. We get it as 11 followed by 5 zeros, centimeter. Let the wheel makes revolutions in 10 minutes. Therefore, n times the distance traveled in one revolution will be equal to the distance traveled in 10 minutes. So the number of revolutions into distance in one revolution will be equal to the distance traveled in 10 minutes. That is what we understand from this, if I consider the number of revolution to be n will be equal to the distance traveled in 10 minutes. It is 1 followed by 5 zeros divided by the distance in one revolution will be equal to the circumference of circle we have learned in our lower classes. So 80 pi, instead of pi I'll consider 22 upon 7. This will become equal to 35000 upon 8. You can further simplify and cross check it. We get it as 4375 revolutions. So therefore we'll take 4375 revolutions in 10 minutes. Question number 5. This is the last question of the exercise. Check the correct answer in the following and justify your choice. If the perimeter of the area and the area of circle are numerically equal, then the radius of the circle is, let me consider the radius of the circle to be r. So let me mention that, let the radius of circle equal to r. So the perimeter, they have mentioned as perimeter, it is same as the circumference, will be equal to 2 pi r, and the area will be pi r square according to the question. The area and the perimeter are numerically equal, so 2 pi r will be equal to pi r square. Pi will get cancelled, r and r will get cancelled. We get the radius as 2 units. So the answer is option A, 2 units. This completes exercise and we end today's session. In the next session, we will take up the next exercise. That's all for today's session. Thank you.